Okay, we, in class today, one of the things we just talked about is approximately when we think we'll be done in this class, and that's somewhere around possibly April 18th, somewhere around there. And then we wanted to mention what's called your life skills project, and spent a little bit of time on that. That's just something that you can make for yourself for in the future, whether it's in an apartment, a dorm room. These are just things that students have done in the past. Of course, Mother's Day is coming up, Father's Day is coming up, or something that you just want to decorate your own room for. And there's lots of things that we've done. Wooden crosses, picture frames, flower boxes, birdhouses, anything to that nature. But then the question came along, what is tomorrow going to be like? Well, we're going to just draw sort of amino acids and link them together to make proteins. So we're just going to do two of them. The first one that was mentioned was asparagine. So for instance, maybe we would say the protein fibrin, okay, which is used for blood clotting, because there's a lot of assorted functions that these proteins do. And maybe this is just a small fragment of what fibrin is that has the assorted amino acids, which is, okay, so we said glycine. No, you didn't say glycine. Sorry, you said asparagine. Yes. Okay. So ASP, okay, your amino acid. Okay. And one more. And one more. Threonine? Serine. Okay. And I just put this up here for my convenience. I don't know, asparagine, valine, and serine. Because that might be aspartic acid, but regardless, we're going to draw it as asparagine. Okay? So, what can you use to your benefit when you hear asparagine? For one. Okay, it has an amine group, just like this is an amine group. Okay, then of course that and that. And then every one of these that are quite complex at least has a CH2 group on it. And then in this case, we've got another carbon. Okay, and perhaps I might have to do a little work on these myself, because is there another carbon or is there a double bonded oxygen? There's a double bonded oxygen on there. That's right. Which means now we go back to our asparagine, which means what type of group is on this last carbon? There's an NH2 making another amine group. Okay? So for all practical purposes, what is just slightly a little larger than asparagine? Glutamine, which means you're going to add just one more carbon on here. That's the only difference between those. Okay? Then we've got our OH group. We'll link these together in just a moment. Okay? Then we've got our valine. Kind of the spatial orientation is off just a little bit. Okay, the clue that we can use for this valine, because right now we'd probably be looking at alanine, okay, because it just has a methyl group on there. Valine, however, doesn't have a methyl group derivative, but rather an isopropyl group, which means, now whether you draw these in a straight line or if you like to have these slanted, okay, we'll just kind of do half and half. Not quite straight, but yet isn't quite a pronounced V either. There is our valine, and then finally our serine that we would have. Of course, again, we ran out of space. I'd like to keep this content for the general chemistry students, because of course that looks familiar. Yeah, very good. Okay, so then Okay, and again, there's our acid group. And then serine means nice and really somber, maybe. Okay, because, because again, it's probably not the best way to look at this for high school students, because I heard it. What are we putting for that fourth bond on there? Right. Okay. So when we look at serine as far as cysteine, cysteine's quite similar to this, except what would we possibly do with this oxygen? Not only are we going to get rid of it, but we're going to put what there instead? Okay. If this was cysteine, but it's not, okay? We'll go back to what it was before, which was, again, serine. So we'll just show where these get linked together for this protein, because, again, amino acids are the building blocks for all proteins. So what specifically happens here between the maroon or purple and the black? Okay? So when you do this, okay, because this will probably be half and half. The front side, you're just drawing amino acids only. The back side might say assemble this protein, which has 3 or 4 amino acids put together. Okay? So then what you would illustrate and then redraw is, like you correctly said, okay, we know that that OH group comes off all the way, but does this bond get taken away too? No, it does not, because once this disappears, we take that hydrogen away, okay? And then once we've done that, this hydrogen, it's not that it migrates, but one of the things that we had said, in order for these to get linked together, is that this hydrogen comes down here now, okay? So there's our H2O. Now that that hydrogen's down here, these have to link somehow, and that's where that bond goes to there, okay? I want you to be able to associate that correctly. Okay, so again, that bond stays, that hydrogen's now down there, that one left with the dehydration, and everything still the same. And then on the very left side, of course, nothing happens here because nothing's bonding to this amino acid. As this keeps on going and going, that dehydration takes place and that is made. And of course, what happens is something that you learned 2 years ago in biology. How are proteins assembled? Well, it's a type of synthesis. The directions go all the way back to this molecule in the nucleus. And we even looked at that. This is where it gets to be a little tricky, because there's an H and an H. That's correct, because this is what sugar? Close. Deoxyribose. Because, again, this is where it's tricky, because there's no oxygen there. Okay. So these proteins get assembled because of the directions of DNA, and as that process of transcription and translation is putting these peptide bonds together, and that's what's happening here. And again, it's not just proteins that amino acids are important for. They're also important for hormonal function. And those hormones will drive many different growth factors that happen in the body as well. Okay. Front row. Good. Back row. Okay. Here again, like only one student will understand this. Mrs. Carson looks at young Dr. Carson and says, you don't need the book, because where's the book? Exactly. The book is inside you. The content is there. Just once the pencil gets going, it'll all come back to you. Okay, so evaluation tomorrow, and then we will move on to the lipids next week. Okay, catch up to you next time.